All right, Kamri, here we go. Check this out. So the idea here is that you need to prove that the triangles are similar to each other. Okay. So for this one, it wants you to say that this leg A to B and A to C is similar. The proportion is exactly the same, congruent, to A to C and A to D. So if you pull out this triangle, this is the little one, and in the big one, you got to prove that they're similar to each other. Okay. So I typically like to draw them separately. Okay. So the little one looks something like this, and this is C, and this is A, and this is D. And then the larger one, okay, is well, actually, forget that. Let me make it more precise. Híjole, hang on. I don't know how to erase here. The larger one, this one, okay, this is B, and this is A, and then this is C, but this one's 90-degree angle right here. So if you can prove that they're similar, then their proportions are the same. All right. So what we got to do is here, look, A, this is an A right here. For sure they're both sharing A. So we could put a mark here and a mark here, and we can start off. Angle A is congruent to angle A, and that is reflexive because you are yourself. Okay. So good. We got one angle proven that they both share. Now, angle D, we call it ADC. This one right here is also congruent to ACB. And because they're both 90 degrees, okay? And they're 90-degree angles, right angles are 90 degrees, right? So they're both congruent. I don't know what you write that. Okay, so now we have two angles that are congruent. So, therefore, this angle has to be equal to that angle. It has to be, because both of these are the same, so the leftover. And I think that's called, so then we could say angle, and let's call it CAB, which is the first one. Plus angle ADC plus DCA. So basically this angle plus that angle plus that angle equals 180, because that is what all triangles equal to. Okay, your reasoning is all triangles add up to 180. And now you do the same for this other one over here. So angle A again. So it's actually called CAB. Look, you have CAB here again. And then the second angle was the right angle, ACB. And remember, these two are equal to each other. And the last angle was ABC. Okay, same theorem. Now, therefore, since these are the same, and these are the same, therefore these are the same, and that's called I forgot. Therefore angle BCA is equal to, congruent to angle ABC. And I think this is called if A equals B and B equals C, therefore C equals D. What was that called? Transitive, commutative, I forgot, okay? But there's a reasoning for this one, and I think it's the one that has if A equals B and B equals C, then A equals C, that one. All right, I'll skip that idea for now, but I forgot the exact wording. So, therefore, okay, therefore the triangle, now you can put triangle. If all these three are equal, so now we've proven that this one is equal to that one, then the triangles are similar. Then triangle A, I'm going to go ADC. I'm going to put the 90 degree in the middle. Okay, ADC is similar to triangle ACB. See the 90 is the C, and that was because of angle theorem. Okay, they all have angles. Okay, so if you've proven that they're similar, therefore the proportions of each then therefore A over B and A over C is congruent, is equal to, it's actually not congruent, it's actually equal to A over C over A over D. Okay. And you could put a step in the middle defining that AB is corresponding. You could say AB is or corresponds to, okay, AB, so A to B, this one is your hypotenuse. It corresponds to A to C. Okay, so these correspond to each other. Okay, and you could also put in the same one that the shorter leg, AC, that's AC, AC, and then AD. Oh, there is a third one. We're looking at AD. So there's the third triangle. Excuse me, right here. This is D right here. So this is the shorter leg, A to D, and that corresponds to this leg right here, C to A. So this is the hypotenuse, and this is the hypotenuse. And this is the shorter leg, and this is the shorter leg. And this is the longer leg, and this is the longer leg. Okay, Mia, so this is kind of the idea for proving proportions of triangles. You got to prove that they're similar first, and we did this one through AAA.